Dear students, this is our second module on security attacks. And in this module, we will be mainly focusing on security attacks that can arise from inside the operating system. So in previous module, we have learned that there are different ways we can stop unauthorized access to the operating system. However, if by some means some user can get access to the inside of the operating system, then that user can look for the information of the interest, whatever he or she needs. So for example, if a user wants to access a computer of security agencies, so that user can try to identify the information which is very important for that user. And similarly, in for other organizations like education sector, so if for example a user can get unauthorized access to the system, the user can change, for example, the grade of the students or some other important informations that can be accessed, and it can also place or insert destructive software wherever the user wants. And it is very straightforward if the user get access to the administrator password. However, if the administrator password is protective enough, then it would be a little bit tricky. So this is why the administrator password should be very strong, that cannot be judged or guessed by a normal user, and that should contain the combination of small letters, capital letters, some numeric values, and some special symbols. So then it becomes difficult to guess or track. So if there is not access available about administrator password, then using the general user's account, the user can trick the operating system to grant unprivileged access. How? For example, that user can generate such a instruction which tries to trick the operating system that this access can be given to that particular user, for which he or she should be denied. For example, it can trick memory manager to get access to those cells outside the allotted area. So we learned that every user and every process has a dedicated area, and no user can access the area from other user or process. So it can trick the operating system that please give me such a access to that particular area. How? We will learn in the next slides. And then it can also trick the file manager to access files for which that user should be denied. So this means that user is not a privileged user for that particular file. So for example, if we see that today's CPUs are somewhat smarter, then they give access to the allotted memory locations only. Otherwise, operating system would have been thrown outside the main memory. For example, there are some special purpose registers. So like there is a register, like we can say R1, and this is R2, and here is the RAM. So in R1, the address would be saved for a particular process, for example, process 1. Like we can say that this process is the operating system itself, and it is saying that it is the R2 is having the address of, for example, 500. So how it proceeds? It sees in these special purpose registers that whether this process is asking access outside these limits or not. So if the process P1 is wanting access only within these limits, then it would not be a problem. However, if process P1 says that I need an access to 509th memory location, so that would be wrong, and operating system will try to put a limit on it. And if it is done by any process that needs access outside the allotted area can change the value of special registers. So for example, we said that it was 100 and this was 500 and this was memory, and this memory is 100 to 500. So if process P1 comes and it needs access somewhere here at the location of 600, so what it will do, it will change this address from 500 to 600. So such a trick can be done by a process which want access to the area that is outside the memory. So how to handle such a situation? So operating system has given an opportunity to be run under the privileged and non-privileged access modes. So in non-privileged mode, limited number of instructions can be executed. For example, no instruction can be executed that is going to change the address of R1 or R2 or the special registers. There is no instruction that can be executed to see the access of file manager, to get the access of another file, or only the privileges that are pertaining in the non-privileged area will not be accessible. So in privileged system, user would be able to execute all kind of instructions, whether they are special or normal instructions. So whenever operating system is booted, the operating system is in the privileged area or privileged mode. And as soon as the CPU is assigned to a process, another process other than the operating system, at the same time, operating system transfer the mode from privileged to non-privileged. And in this non-privileged access, no special instruction can be executed, as we have studied in the last 2 or 3 slides. So, however, if that is compromised by any means, so a process can change time slot for itself to get more access in the CPU. It can change the addresses which we have discussed. And if a process is allowed the access to peripheral devices, it can read and write on the peripheral devices without the supervision of file manager. And if process is allowed to access memory beyond its address, it can read and write unauthenticated data. And maintaining security is important for administrator and for operating system itself. So if we summarize today's module, we have learned about security threats which can arise from inside the operating system and how they are compromised with respect to administrator and general user account, and what are its inherited problems and how those are solved. And even then, if it is compromised, then which kind of security threats are arising from inside the operating system.